All right, today we're going to talk about scientific notation. So scientific notation is nothing new to you. It's just another way of writing really big or really small numbers in a simpler way. Okay, so scientific notation is a compact, that's the first word we're going to put on the line here. It's a compact way of writing very large numbers or very small numbers, just like what I said, okay? So it's a compact way of writing very large or very small numbers. Really, the most important thing is this right here, okay? In order for a number to be written in scientific notation, this number here, A, that's just our algebra way of confusing everyone, just throwing letters in there, but it just represents that numeric part of the scientific notation, must be bigger than 1. It can be equal to, but it must be greater than 1, and it must be strictly greater than 10. Okay? So here are the steps in the next row to convert numbers to scientific notation. So step 1, we will move the decimal so the new number is between 1 and 10, okay? And then we're going to write using powers of tens the exponent that matches the number of times the decimal was moved, okay? If we move the decimal to the left, okay, we move the decimal to the left, the exponent is going to be positive. If we move the decimal to the right, because sometimes we have to move it to the right to make sure our number is between 1 and 10, then the exponent is going to be negative. You might at this point be like, what? I forgot all about how to do this, but don't worry, we're going to do some examples and you're going to be just fine, okay? So let's look at some examples here. So first, we are going to convert, I wrote the definitions again up here, but you know what, I'm just going to write left, it's positive, right? Left is positive. If we move it to the right, it's gonna be negative. Sorry, my pen seems to be skipping out. I don't know what's going on here. Okay, so when a number is written just regular, it's called standard form, okay? And in standard form, the decimal always lives at the end of the number here. Right here. There's the decimal. Well, I guess I could have made it a little bigger. Right there. That's where the decimal lives. It always lives at the end of the number unless it's in here somewhere, and I do not see it in here somewhere. So, for the sake of this practice, I'm just going to write all my decimals right there. Now, I have to move this decimal to make the number bigger than 1, but smaller than 10. So I am going to go 1, 2. So I moved 2 places. So now I have 5.4. And then here's the weird part. It's always times 10, because that's the scientific notation part, to the whatever I did. I moved to the left, right? We moved to the left. I'm going to put a little arrow here. And so our exponent's going to be positive. And you're like, well, what's the exponent going to be? Well, how many places did you move? We moved 1, 2 places. So my exponent is a 2. Okay, let's look at the second example. I'm going to move this decimal so that my number is now bigger than 1 and smaller than 10. So 1, 2, 3, 4, 5. I moved 5 places. So now I have 9.37. And don't write all the zeros. That's why we're doing this. We're writing really big numbers in a fancy, compact way. So 9.37 times 10 to the, how many times did I move my decimal? 1, 2, 3, 4, 5 to the 5th power. That's my exponent. All right, now number 3 is even bigger of a number, right? So let's count how many times we move it. 1, 2, 3, 4, 5, 6. Sorry, I have a hard time writing on here. So now we have 1.852 times 10 to the 6th power, because I moved 6 places to the left. All right, number 4. 1, 2, 3, 4. I moved 4 places. 7.682. And we always write all the non-zero numbers, okay? That's important. Don't just write 7.6 because that's not the number. It's 7.682 times 10 to the 4th power because I moved 4 decimal places. All right, last one in this set. So here's my decimal. I need to move it so the number is bigger than 1 but smaller than 10. 1, 2, 3. I moved 3 places. 4.671 times 10 to the 3rd. Perfect. So now we just rewrote those 5 numbers in standard form to scientific notation. All right, so now we're looking at really small numbers. Remember, if we move the decimal to the right, it's going to be a negative exponent. All right, the decimals are all very present here. You can see them. Here is the decimal right there. Now I want to move it so that the number is bigger than 1 but smaller than 10. I'm going to move 1. Oops, that's just too big. 1, 2, 3. So 9.82 times 10 to the negative 3. Think about this. If they're really small numbers, they're going to have negative exponents. If they're really big numbers, they're going to have positive exponents. All right, number 7. There's the exponent. Now we need to move it so that the number is bigger than 1 and smaller than 10. So 1, 2. So 5.273 times 10 to the negative 2. It's really important that we make sure that exponent is negative because we moved the decimal to the right. All right, number 8. There's my decimal. I need to make this number bigger than 1 and smaller than 10. So 1, 2, 3, 4, 5, 6. I had to move it 6 times. 1.4 times 10 to the negative 6. Beautiful. All right, number 9. Here's my decimal. I need to move it only 1 place. That's okay. This is scientific notation. So now my number is 2.58 times 10 to the negative 1. Oh my goodness gracious, we have a lot of moving going on here for number 10, but let's all do this together, okay? So we start at that decimal and we move 1, 2, 3, 4, 5, 6, 7, 8, 9 times. I had to move that decimal 9 times to make this number bigger than 1 and smaller than 10. So remember, it's always times 10, and then we use that negative exponent because we moved 9 places to the right, to the negative 9th power. Okay, so hopefully you're okay with that. Really small numbers, ones with lots of decimal, ones that have the decimal apparent, really tiny. Moving the decimal to the right, your exponents are going to be negative. Really big numbers, when we have to make the decimal appear, because it's always at the end of the number, and we move them to the left to make the number between 1 and 10, it's going to be a positive exponent. All right, so now we're going to determine if the number is correctly written in scientific notation. If it is not correct, we're going to correct it. We're going to fix it, okay? First off, what I'm looking for this first number. Is that number 2.98 bigger than 1? Yes. Well, is it smaller than 10? Yes. So this is gorgeous. We're just going to leave it, okay? Number 12. Is this number bigger than 1? Yes, it's 11.4. Is it smaller than 10? No, it is not smaller. It's too big, so we need to move it. So no. We need to move it one more place to the left. One more place to the left. Remember, when we move it to the left, that's positive, so we're going to add 1 here. So now I have 1.14 times 10 to the 4th power. Beautiful. All right, let's look here. Now we have another example. Number 13. I'm looking at this number 85.1, and yes, it's bigger than 1, but it's definitely not smaller than 10. So this is a no. So what we need to do is we need to move the decimal one place to the left. So we move it to the left. It's positive. We're going to add 1 to our little exponent here. So that gives me 8.51 times 10 to the, now be careful because this is negative 5 plus 1. Negative 5 plus 1 is negative 4. Perfect. Now, that number is bigger than 1 and smaller than 10, and it's beautiful. All right, last one. All right, 6.8. Is that bigger than 1? Yes. Is it smaller than 10? Yes. Yes. I guess we could write yes here. We could have wrote yes up here too. I just put a check mark because I'm silly. Silly, silly, silly. All right, let's take a look at the other side here. Now we're going to be working backwards. Converting to standard form is even easier. The exponent tells you the direction and the number of places to move, okay? If it's positive, we're going to make it a big number, okay? So if we start with 6.38 and my exponent is positive 3, I need to expand this 3 places. 1, 2, 3. So there's my exponent now. If there's nothing above, we're just going to drop in a 0. So this is 6,380. Okay, now we're going to do it again. We got another positive exponent here. So I'll just keep this color schema going, okay? 2.085. I need to make this, right? It's a positive exponent, so it's going to be a big number. So we're going to move that decimal. 1, 2, 3, 4, 5. We're going to drop in the zeros where we have missing digits, and our number is now 208,500. Okay, number 17. It's a 1, which is nice, so I only need to move it 1. So now it becomes 98.2. All right, number 18, I'm going to have to write this out. So I got 5.388. And we need to move it 6 places. 1, 2, 3, 4, 5, 6. So we're going to drop in 3 zeros now in this missing spot. And our number is 5,388,000. Don't forget all those zeros. And I'm just going to put my commas to mark that. Okay, wonderful, wonderful, wonderful. So I'm going to make just a little note on my paper. Maybe you want to do that too. So if it's positive, we move it this way. And then down here, if it's negative, we're moving that away, right? Positive, big number. Negative, small number. So we make it even smaller. So for number 19, we only need to move that twice, right? 1, 2. So this becomes 821. Now, for number 20, because I need to move my decimal to the left because it's really small, I'm just going to leave it set right where it's at, and I'm just going to move it 1, 2, 3, 4, 5 times because my exponent was -5, and drop in zeros there. So I have 0.1, 2, 3, 4 zeros, 525. Fantastic. All right, a couple more. I know I said you try here, but I'm going to change my mind. We're all going to do this together. How about that? So, negative exponent means it's a small number. I got to make it even smaller. We're moving this way. So 1. So think about the opposite. You know, when we convert a standard number, we know the big numbers, we're always going to move our decimal to the left, right? And they're positive. So when they're big numbers, when we put it back together, we go to the right, right? We just do the opposite. So when they're really small, we move to the right. So that means when they're really small, we convert to standard form, we move to the left. So just think really small number. Okay? Oh boy, I got to move a lot for number 22. Here we go. It says -7. So 1, 2, 3, 4, 5, 6, 7. I almost ran out of room. So that's 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros, and then the 162. Now that's in standard form. Oh my gosh, we even got to go even farther. If you want to think about that, right, I can move it one place and then I get a whole bunch of zeros. Well, that means I have to put 8 zeros in front because 8 plus 1 is 9, and I need to move 9 places. So we can go ahead and do that. So 1, 2, 3, 4, 5, 6, 7, 8, 2, 4. If you want to go ahead and do your little thing, go right ahead. So it was 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a lot. I didn't give myself a lot of room. All right, number 24. Here we go. We need to move it 2 places. 1, 2. That wasn't too bad. And I put that 0 out front just because it lets me know that that's where the decimal is, right? And that's how your calculator writes the answer too. All right, 0.06018. That is fabulous. All right, comparing numbers. Now we're going to compare these numbers. We are also going to be doing more of this tomorrow. So, you know, keep this in the back of your mind that we're going to be comparing these numbers. So first off, if you look at the exponents, that's going to tell us a lot of stuff, okay? I have an exponent of +5 and an exponent of +3. Who is bigger? 5 is bigger than 3. So guess what? That number, 3.128 times 10 to the 5th power, is bigger than 7.42 times 10 to the 3rd. All right, let's do it again, number 26. All right, instantly I go to the exponents because I'm like, all right, 7 is definitely bigger than 4, so no matter what, that number is going to be bigger. Now, when they get negative, that's when things get crazy. Because remember, the bigger the negative, the farther away from 0 the number is, so the smaller it is. So this is kind of different. If you see a bigger negative, that is smaller than this guy. So that means he's bigger. Like that. Okay? Look at number 28. All right, who's smaller? -6 or -1? Or maybe I'll say who's bigger, right? If you're thinking -6 is bigger, -6 is farther away from 0 than -1. So -1 is actually bigger. Like that, okay? We will talk more about that tomorrow. Do not worry, do not worry. All right, applications, aka word problems. I know you love it. All right, first off, let's look at this number. is this number really big or really small? If you're thinking really small, you're thinking correctly. So that's telling me I'm going to need to put in a negative exponent. Let's get how many times I need to move this decimal so that the number is bigger than 1 and smaller than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Whew. 2, you could put 2.0 if you wanted to, but I feel like I just wrote enough already. 2 times 10 to the negative 15 power. That's how we would write that. Doesn't this look so much nicer than that? Ooh. Ah. Anyway, okay. All right, number 30. The distance from Earth to the Sun is 9.3 times 10 to the 7th miles. The distance from Mars to the Sun is 2.28 times 10 to the 8th mile. Which planet is closer and by how many miles? Give your answer in scientific notation. First thing I want to do is I want to expand these numbers. So we're going to take 9.3 times 10 to the 7th, and we're going to write it in standard form. So that means this number is really big, and I need to go 7 decimal places to the right. So 9, this is 1, 2, 3, 4, 5, 6, 7. That's 7 total, right? Because we started between the 9 and 3. 1, 2, 3, 4, 5, 6, 7. I'll just put the decimal there because we know it's there. All right, let's convert the distance from Mars to the Sun in standard form. 2.28 times 10 to the 8. Now I need to move it 8 times, okay? So there's 2 digits right here with the 2 and the 8. So that's 1, that's 2, and then followed by zeros. 3, 4, 5, 6, 7, 8. What we're going to do is we're going to subtract these numbers. Oh my. But I noticed that the number in the bottom is bigger, so I'm actually going to rewrite it because I don't want it to be a negative. All right, so we're going to take the distance from Mars and then subtract the distance from Earth. So that is 228 million miles away. That's a long way away, isn't it? All right, then we're going to subtract the distance from Earth to the Sun, which was 93 million miles away. I think I'm missing a 0 here on my other number. All right, when we put that in our fancy little calculators, we get a difference of 135 million. I'm so sorry, please forgive me. 135 million. Let's rewrite this number in scientific notation. Right, we know the decimal lives at the end. 1, 2, 3, 4, 5, 6, 7, 8. So I get 1.35 times 10 to the 8. That is the distance. I mean, that's how much closer Earth is than Mars to the Sun. I thought Mars was closer, but I guess not. I guess it's just a red planet, not because it's hot. This is just cool. It's just red. All right, and this is Earth is closer. All right. See, whenever you're like, when am I ever going to use math? Look, isn't that fascinating now that we know that Earth is, 1.3 times 10 to the 8th power miles away? Don't you feel better? Now you can sleep tonight. And be like, oh my gosh, I feel so happy. All right, guys, well, you got your worksheet. That's their homework for tonight, so make sure you turn it in or give it to me. You submit it somehow. Get it in. Get those points. Have an awesome day. If you have any questions, hit me up on Schoology. Bye.